Hi students, this is Mr. Yao. Today we are going to begin learning about projectile. It is heavily related to all the things we have learned so far, so let's review something from 4.11. That's going to lead us into projectile. So question A, write a quadratic function from the given graph. So you should be able to tell the x-intercept here we have 0, 0, and then here we have 5, 0. As for the vertex, we have 2.5 or 5 over 2, 100. So I can easily start setting up as x-intercept form, or you can set it up as vertex form either way. So I suggest you actually pause here and try to work it out by yourself, since this is something we have learned before. So I can set it up as a times x, because it's just x minus 0 here. So it's just x, and the other one would be x minus 5. Now I can plug in the 5 halves, f of 5 halves, that's going to be a times, the x is 5 halves, then it's going to be 5 halves minus 5, which gives me, that's 5 halves, that's negative 5 halves, so it's going to be negative 25/4 a, which equals to 100. So I would actually get a equals negative 16. I can put it back to the standard to the intercept form right here. So f of x is negative 16x times x minus 5, which is going to give me negative 16x squared. That's a minus 16x times a negative 5, so it's going to be a plus 80x. That is A. Now let's see B. For this one, you can use the intercept again, which is negative 1/2, 0. And the other one is 5 half 0, or you can choose to use the vertex, which is right here. If you look carefully, that's from 30 to 40. There are 5 different breaks, so that's going to be actually 136 because there are 3 of them, so which makes it 36. And the y-intercept, of course, is 0, 20. So I'm going to try setting up as a vertex form for this one. F of x equals a. Vertex form, this 1 is going to be x minus 1 squared. Then that 36 on the end is a plus 36. Okay. And now I'm going to plug in a 0, 20. So f of 0 is a times 0 minus 1 squared plus 36 equals 20. And that's going to be 1 here. So a plus 36 equals 20. So a is negative 16. And I have f of x equals negative 16 times x minus 1 squared plus 36. You can open all the parentheses, that should give you negative 16x, and then it's going to be a plus 32x. And on the end is going to be a plus 20. So that is B. Let me write the other one down as well, so you can answer this question. F of x equals negative 16x squared plus 80x. What do you notice about the two functions that you found? The first thing you might notice is they're both starting with negative 16x squared. The second thing you might be wondering, you might be notice is this is a positive 32x and this is a positive 80x. So far it's going to be a positive number in front of x. That's something you may notice. So these all are going to lead us into projectile motion, because that, especially that negative 16, is how projectile motion is. So projectile motion is the motion of an object thrown or projected into the air, subject to only the gravity. The object itself is called a projectile, and its path is called a trajectory. You are going to learn more about projectile in the future, especially in physics, or wait until you get to calculus for math. But this is an important motion that you actually see every single day. So now let's put them together. If you have noticed, the graph actually says height and time, height and time. So you can pause here to try to think if, well, 2.5, 100 is right here, and 50 is right here, and in this case 136 is right here, and 020 is right here. You can pause right here and start thinking, if I tell you this is a height time graph, what actually do these points represent? So here, A, hopefully you have given some thoughts. 2.5 is actually a number right here, which is on the x-axis. And that tells you is going to be the time. But the time for what? Well, this happens to be the vertex, which is the highest point. So the 2.5 actually represents time to the maximum point. As for 100, that is the height of maximum point. So it's going to be maximum height. So time to maximum height for the 2.5, and the 100 itself is the maximum height. As for 50, if we're saying this is height, the 0 is clearly telling us the height right now is at 0, which is the ground. So the 5 actually represents how long it takes to hit the ground. And to think it the same way, 136 is the vertex, so 1 is gotta be time to max height. And 36 is gotta be the actual max height. As for the 0.20, well, this time is not an x-intercept, it's actually the y-intercept, it's on the y-axis. And this 0, since it's about 0 time, it tells us when it starts at the very beginning, the 20 is going to be the initial height. So you'll see already with the graphs and something we already know, you can come with some pretty good story problem conclusions already. So now let's have a look a bit more into details. When an object is going through projectile motion, including falling straight down or going straight up, the height time graph will be a quadratic function. It is going up, the object is going up, the graph will open down because it's like that. If it's going down, the graph will actually open up because it's kind of just like going super fast. But this is actually not quite important because that's not something we cover much in this unit. Now here are the two formulas. You may have noticed the only difference between these two formulas are the numbers right here. In feet it is -16 and in meter it is -4.9. You will learn in the future these all relate to gravitational force. Just different units. The -16 actually comes from the gravitational force in feet, which is 32. And the 4.9 also comes from the gravitational force, but this time from meters, which is 9.8. Now we do have a lot of variables in these formulas, so let's have a look. H of t, of course, we're trying to calculate the height at time t, so we can use that to present. The t is going to be time, and since these things typically fly pretty fast, the t is always in seconds. H0 is the initial height because in the previous example, you see that 20 is the number on the end, and that is the initial height. As for the v sub 0, these are initial velocities. So you have to launch it up, have a launching speed so that it can form a parabola, or in this case, a projectile. If it is positive velocity, it means it's launching upward, so it's going up. If it's a negative velocity, that means launching downward, which we won't actually work with a lot. Now, based on the previous examples, you should come up with some conclusions to find the maximum height. So let's say this is what we have. The maximum height is going to be this part. Well, that is going to be the y value of the vertex because the maximum height is going to be at the vertex. So it's the y value in vertex. To find how long it takes to reach the maximum point, that would be this portion. So again, this is the middle, and this is right here. That is representing the time, so we are looking for the x value in the vertex. The x value in the vertex. To find how long it takes to hit the ground, in this case, hitting the ground is going to be right here. So that is looking for the time right there. So you are actually looking for the second x-intercept, or the x-intercept that is more on the right. Lastly, find initial height. let's say you give it a graph. Let's say this is our graph. Initial height, the c would be right here. That is the initial height c. So these are some general information that could help us with solving the examples. Now let's go have a look at some examples. Example 1. We throw an object outward from the top of a building. The height h is given in the equation in the formula. What is the height of the building? Well, it's starting from the top of the building, which means if we're looking for the height of the building, we are looking for initial height, which actually is the c in standard form. So that is going to be 912 and the unit feet. Next, what is the highest point that the object reaches, and how long does it take to reach the highest point? Again, this is x in vertex. This is y in vertex. So no matter what, we are working with the vertex form. So let's have a look. The x in this case is actually not x, it's t, and this is h. So t is negative b over 2a, because that's the x value of the vertex. Negative b is 256, and my a is 2 times negative 16, which is negative 32. So it's going to be 8 seconds. As for my h of t is not going to be h of t anymore, it's h of 8, because my time is 8 seconds. So I'm just going to plug it back in. Negative 16 times 8 squared plus 256 times the 8, which plus 912. So in this case, that is going to give us 256 times, so 1024 plus the 912, which is 1936. Don't forget unit feet. That is example 1. So again, when you look for the maximum height and how long it takes to reach there, you're looking for the vertex. Example 2. An object is launched at 19.6 per second. So that's why the formula in this case is going to be negative 4.9. And first is asking how tall is the platform. Again, that's where we started. It's asking it's launched from a platform. So that is going to be 58.8 feet. Not feet, meter. Next, when does the object strike the ground? Again, that means we are looking for the x-intercept. So let's have a look. The x-intercept in this case, we're actually using t. So t equals negative b, which is negative 19.6. And the bottom is 2. So it's going to be 2 minus, not 2 minus, 2 times negative 4.9. That's the 2a part. As for the top, plus or minus square root of 19.6 squared minus 4 times negative 4.9 and then times 58.8. You can put all that in your calculator and you should actually get 2 different answers. The square root part is going to give you plus minus 39.2 and the bottom is negative 9.8. So you are going to need to separate them since you have a plus and a minus, so separate them to simplify. The plus one will actually give you the, let me write it here, the plus one is actually going to give you a negative number because we're dividing by negative 9.8, it's going to give you a negative 2. The minus one, however, is going to give you a 6. Since we are talking about time, negative 2 doesn't make any sense, so that wouldn't work. The answer would actually be 6 seconds. That's how long it takes to strike the ground. Now, example 3. A nail falls off an airplane at 300 meters. How long does it take for it to hit the ground? It's using meters, so we gotta set it up with negative 4.9 t squared. Next, we need to know about v sub 0. In this case, if something is just starting to fall, the v sub 0 would actually be 0 because, it doesn't have a speed at the very beginning until it starts falling more. So it's going to be a plus 0t, and on the end, it's going to be a plus 300 because that's our h sub 0. To remind you, negative 4.9 t squared plus v sub 0 t plus h sub 0. That's our formula for the projectile. Now it's time to see how long does it take to hit the ground. So equal to 0. You can choose to use the quadratic formula. T is negative b, so 2 times, 2a on the bottom, 2 times negative 4.9. On top, negative b is basically 0. Plus minus b squared is still 0 squared, and minus 4 times negative 4.9 times 300. So you actually type in that whole thing into your calculator. That is going to give you the top as 76.6811. But you have a plus or minus. So on the bottom is negative 9.8. For the positive one, you are going to get a negative answer, which is going to be negative 7.82. However, the bottom one, you are going to get 7.82 as a positive answer. And clearly, since we're talking about time, that negative wouldn't work. The final answer is 7.82 seconds. That is example 3. Next, example 4. Launch from a cannon with an initial velocity of 30 meters per second. Since it's meter, f of x, not f of x, let's actually use the right one notation. H of t, it's going to be negative 4.9 t squared. And then initial velocity is 30 meters per second. And it is 3 meters above the ground, so plus a 3. We are looking for the highest height, the time, and we're also looking for the actual height. So let's start with the time. That's negative b over 2a. So it's going to be negative 30 over 2 times negative 4.9. And that is going to give us 3.06 second. And we're going to plug it in. H of 3.06 equals negative 4.9 is 3.06 inside the parentheses, then squared. So then plus 30 times 3.06. 30 times 3.06. Then at the end, we have a plus 3. So altogether, we are going to have 48.92. Don't forget the unit, meters. That is example 4. Now, last example, example 5. A coin is tossed upward with an initial velocity of 30 feet per second this time. So we are going to need to use not negative 4.9. We're going to use negative 16. T squared. And it's from an altitude of 8 feet. So first, the initial velocity is going upward. So it's positive, so plus 30t. Then from a platform that is at 8 feet, so plus 8. We are looking for the maximum height and time again. So let's start with the time. T equals negative b over 2a, which is negative 30 over 2 times negative 16. So basically, we have 30 over 32. And since we're talking about time, a fraction time wouldn't make quite much sense. So it's going to be decimal 0.9375. Let's put it up, plug it in. 0.9375 negative 16 times that number being squared. So negative 16 times 0.9375 being squared. And then plus 30 times that number. Plus 30 times 0.9375. And then at the end, don't forget to add the 8. That is going to give us 22.0625. Which is actually in feet. Into set it to 0. Negative 16t squared plus 30t plus 8 equal to 0. Don't forget it's quadratic formula. Negative b, negative 30, plus or minus b squared, so 30 squared, minus 4, my a is negative 16, my c is 8. all over 2 times the negative 16. So let's calculate it out. Negative 30 plus or minus, I'm going to calculate out my inside the parentheses. So it's going to be the square root of 1412. That is going to give me 37.57658, or actually 9, all over negative 32. So I'm going to minus 30 first. That is going to give me negative 0.236, so negative 0.24. That wouldn't work. So I actually need the other one. So it's going to be negative 30 minus 37.57659. And then divided by negative 32, that is going to give me a positive 2.11 second. And that would actually be my final answer. That is everything for example 5. And that's the end of 4.13a. Thank you.